This lesson is on the law of cosines. We're going to start this lesson by dealing with a general triangle, but we're simply going to put it in the xy coordinate plane. So now you can see that we have a general triangle ABC on the xy coordinate plane. A is at the origin, and AB is along the x-axis, and then C is located in the first quadrant at coordinates P, Q. B is located, as I said, on the x-axis. The coordinates of that point are C, 0. We also have an altitude CD constructed on this triangle. Now the first thing I'm going to do is write an expression for P squared plus Q squared. As you can see from the diagram, the segment AD is equal to P, and the segment CD is equal to Q. And since we have a right triangle, ADC, P squared plus Q squared is simply going to be equal to B squared. Now next, I'm going to want to determine an expression for P in terms of B and angle A. Again, if you realize you've got a right triangle here, you can use the trig functions for angle A and get the relationship between P and B. And that is simply going to be that cosine of A is equal to P over B. Then, if I multiply both sides of that equation by B, I get my expression for P in terms of angle A and B, namely that P is equal to B cosine A. Now, I want to find an expression for A squared in terms of C, P, and Q. Now, if I look at this, I notice I have another right triangle, CDB, and if I can use all the sides of that triangle, I can get an expression for A squared. Well, I know that CD is equal to Q. Now, what is DB equal to? Well, if B has a x-coordinate C and AD is equal to P, then DB must be equal to C minus P. Now it is fairly a simple case of using the Pythagorean Theorem to get an expression for A squared. And namely that A squared is equal to Q squared plus the quantity C minus P squared. Now, rather than leave this in factored form as I've got C minus P quantity squared, I'm going to take and FOIL that out so I actually get what C minus P squared is equal to. Now, I want to use what I've learned to get an expression for A squared in terms of B, C, and angle A. So now, if I look at the very first equation or expression that I came up with, that is that P squared plus Q squared equals B squared, I can solve that for Q squared and substitute it down into this latest expression. And if I do that, the expression is going to look like this. Now, if you look at what we've got here, you'll notice that we have minus P squared and plus Q squared, so we can simplify this by simply canceling those two out, which yields us with B squared plus C squared minus 2CP. Now, remember what I said we were doing. We were trying to get A squared in terms of B, C, and angle angle A. Well, notice I don't have angle A there, but I have P. So if I go back up to one of my original expressions for P, we see that P is equal to B cosine A. So I can substitute that for B and get my final expression that I'm looking for. So after we do this substitution, my final result is simply a squared is equal to b squared plus c squared minus 2bc cosine angle A. Now this is known as the law of cosines. You'll notice that it has all three sides of the triangle, A, B, and C. It also has one angle, angle A. There are similar versions of this for b squared and c squared, okay? And they're going to look something like this. So as you can see, all three versions look very similar. Basically, you can almost think of them as being a variation on the Pythagorean Theorem. You have one side of the triangle squared is equal to the sum of the squares of the other two sides minus 2 times the product of those two sides times the cosine of the original, the angle opposite the original side that you started with on the left side of the equal sign. Okay, so you can see in general what the form looks like. Now notice another thing about this, and that is that all three sides of the triangle are there and one angle, okay? So this can be used in situations where you know all three sides of a triangle, but you don't know any of the angles. So let's look at an example. So let's assume that we have a triangle. We don't know any of the angles, but the sides are going to be 3, 5, and 6. So as I said, we don't know any of the angles of this triangle, but we do know the sides are 3, 5, and 6. So let's start out by finding angle A. So the formula I'm going to use is the one that has angle A in it. And that is, namely, that a squared is equal to b squared plus c squared minus 2bc cosine A. Now I'm going to plug in the values for A, B, and C. That's lowercase a, lowercase b, lowercase c. And then solve the equation for cosine A. Now remember, lowercase a is the side opposite capital A, angle capital A. And lowercase b is the side opposite angle B, and lowercase c is the side opposite angle C. So let's crank out the numbers and see what we get.